Welcome for those who just joined us, and welcome back to Programmers Week for those of you who attended our tech talks and keynotes over the past week. My name is Alin. I'm the community manager for mobile and AI communities, and I'll be your host today for the mobile talks that our mobile community will present today. So let's start with the first mobile talk for today, presented by Cristi. Cristi is one of our veteran developers with over 15 years of experience using multiple languages like Ruby, Python, Java, and of course Objective-C and Swift. Cristi is very focused on scalable and testable architectures, and I know one of his passions is unit testing, and he always pushes for best practices on each project that he worked for. So I let him in the next hour to share his insights and best practices regarding this topic. So if you're interested in unit testing, and we strongly advise you to be, feel free to share your questions, and Cristi will provide, I think, his answers based on his vast experience. So Cristian, good luck, and let's start it.
Thanks, Alin, for the great introduction. Hey all, and welcome to another Tech Talk part of Programmers Week 2021. As Alin said, my name is Cristian Kocza, and I'm a mobile/web/desktop engineer at Cognizant Softvision, with a passion for clean architectures, sane programming principle, and a soft spot for functional programming. And in this talk, I'll talk a little bit about the dark side of the unit tests, how to cope with them, and how to avoid their pitfalls. And if you run into them, how to solve them. I encourage everyone to share your questions in the chat module so I can answer them accordingly. And before we start, I just want to mention that the few code samples that are in this presentation are in Swift. However, they apply to all platforms. They are just some small code samples. Okay, so with further ado, let's start. So you're a happy developer. You have a nice workflow where you push your code. The CI starts running the unit tests, the code reviewers review all pull requests, the unit tests validate your code, the reviewers check your code quality, and once everything is good, you merge your feature and you move on to the next task. However, sooner or later, you'll start noticing that the unit tests take longer and longer, which means that you don't get feedback on pull requests as soon as you'd want. And worse, sometimes the test can start failing. And even worse, you don't get reliable failures. Sometimes the tests fail, sometimes they pass. Not the same tests fail. So, and this kind of breaks your mood and puts you in a, let's call, miserable state, because you'll have to hunt down those bugs. You'll have to try to identify why they fail, why they fail only on CI, and why they fail only sometimes. Because the unit tests take longer, and running them in isolation, when you try to run only the failing tests on local, it doesn't reproduce. It's hard to investigate. You lose lots of time, and in worst case scenario, it might even derail your feature. Basically, you miss deadlines because of unit testing. So these are the some things that can go wrong when unit testing. So basically, we can have flaky tests. Flaky tests are tests that don't reliable fail or reliable pass. you see failures from time to time on pull requests. Usually they happen right before a deadline, and that's really annoying. You also have tests that fail only on CI. This is a subset of Flaky tests. Basically, they fail only on the CI servers. They always pass on locally, and having to deal with this kind of test means you need to add lots of logging, lots of prints, and obviously lots of time to figure out what's happening. Tests can also run slow. The more and more tests you add, it's naturally that the test suite will take longer. However, there are tests that are slow by nature. So those only prevent you from getting feedback sooner on your pull request. Basically, you don't find out soon enough that you broke another feature. Another complication is regarding tests that can't be easily written. Basically, the code base is in such a state that you simply cannot write tests, or having to write tests for that piece of code means investing a lot of time, sometimes even more than the development time, which is not necessarily good. Another tests that are problematic are badly written tests. Basically, these tests give you a false sense of confidence. You think that the tests are preventing you from introducing bugs. You see good coverage from those tests. However, in the manner they're written, they don't add much value. I've seen tests that simply execute some piece of code without doing much assertions, or assert on things that are not good enough. And one of the biggest problems, especially when starting to write unit tests, is the lack of time to write them. Basically, you don't have yet enough experience to write unit tests, and this means that it takes longer, and even longer than the development time. And again, this can negatively affect your deliverables. So with all this, in the light of all these problems, you might think, why testing? Well, unit testing is great. Unit testing, I'd say it's a mandatory tool that you should be using. You should not deliver any feature or any bug fix without a test. So what are the benefits of testing? I roughly go through them because I won't be insisting on the positive side on the unit test today. So first thing first, they give you confidence. Once you reached a certain level of code coverage, you have confidence in your code base that it's sane, and any changes that you do, any mistakes that you do are caught in time and they don't get merged. So this is really important, especially on a long time project where the code you written 6 months ago is no longer fresh in your memory, and you don't really understand why the code looks like that. But if you have enough unit tests, then you can be sure then it's safe to modify, to make changes in that code, to make refactorings, for example, without risking to introduce unwanted bugs or bugs that are caught at QA cycle or late in the development cycle, and that at delay. Yeah, unit tests help you reducing the number of bugs. The more unit tests you have, the more code you cover, the less bugs you have in your application, because bugs are caught early in the development cycle. So you don't merge code with bugs. You don't merge code that breaks other features, because that other features already have unit tests in place, and they catch you if you do any mistakes. Unit tests also help you with the overall quality of your code base. Trying to write testable code, and by this I mean code with unit testing in mind, helps you with a good software design. And as we'll see later in the presentation. And not least, unit tests make you feel better about yourself. It's so nice when you have a test suite of a few thousands of unit tests and you see all of them go green and you say, yeah, I did a good job. I didn't break any unit tests. I added new unit tests for my code. And let's move on to the next feature, because I know that my colleagues or even myself won't break the code I just wrote. So what can we do to benefit of all the good stuff that the unit tests give us and prevent the nasty ones to appear, and in case they appear, to mitigate them? So first thing first, and this is something that I strongly recommend and something that I do on every project I join, if not already done, is to set up a CI pipeline. Basically, make this part of the first phase of the projects. Before any line of code are written, just set up a pipeline that runs the unit tests. Even if you don't have unit tests, or you have only one dummy test that Xcode creates, just set up it to have it there, and configure your source control, GitHub or Bitbucket or GitLab, whatever you have on the project, to not allow pull requests to be merged without all tests passing. Once you have this in place, it will be really easy to write tests along the road, because you have the infrastructure, you have the pipeline set up, and when you add new code with new tests, you'll see the tests running, and you'll gradually see how your pull requests get greener and greener, and then you can merge them. I recommend for this kind of checks to use the support that the source control provides you, like with GitHub Actions, with other tools like Travis, Jenkins, TeamCity. Basically, any automated tool that helps you do continuous integration is good for this. Also, be transparent with the product owner or the client about unit tests. Clearly state that you need to write them, include them in your estimation, allocate time for unit tests, and don't let the client push too much on this, because usually clients, product owners are only interested in the features being delivered, and they might not see the value of unit tests, especially if you're dealing with non-technical people. They usually want to see the features seeing the light. So discuss with the client, explain to them why unit tests are important, what value do they have on the project, and what's their impact on the long term for the project. And yeah, don't deliver features without unit tests. Of course, if there are exceptions like tight deadlines, then it's okay to don't have that many unit tests, but that should be an exception. Only in cases where you're in a hurry. Okay, now that you've communicated to the client, you have everything set up, the pipeline, you can start writing unit tests. And now it's time to decide what to test. So keep in mind that not everything is testable. Don't try to test everything. You will not succeed. So first thing first, don't test UI classes. So or UI code, because UI code usually what it does is render some stuff on the screen. It lights some pixels, some blue, some red, some green. And this is not suitable for unit testing because it's hard to test, it's not reliable. The only exception for this is snapshot testing, which basically takes a snapshot of your view and compares it with the next state. Also, avoid testing multi-threaded behavior. So by multi-threaded behavior, I don't mean necessarily methods or code that does multi-threaded stuff, but trying to validate the multi-threaded. Like in example from the left with the add method, don't try too much to validate that the append runs on the main thread. That should be an implementation detail. You should not care from a unit testing perspective if that happens on a main thread or a different thread, because testing multi-threaded behavior is hard, and you can't reliably, you can't ever catch all the possibilities. So the only thing, the only reason you do multi-threaded validation will be to make sure that there are no race conditions. But you can't possibly have unit tests that create all combinations of possible threads and thread contention, and you can't simulate the exact scenario where two threads try to read the same variable. You can write code in Swift with the addition of actors. Actually, with the addition of structured concurrency, you no longer even need to worry about this, because the compiler takes care of that for you. You just need to write actors and be okay with that. Also, split your code. So clearly split your code between UI and business, and try to push business logic code as far away from the presentation layer, and have classes or modules that handle only business layer. Keep in mind, the business logic is the easiest to be tested, because it's just code that computes stuff. And most of the bugs in software are usually generated by bad or misimplemented business logic. So push that code into its own class module and test that class into oblivion. Test everything you can on that class. That's feasible, and that's really even encouraged. And also it gives you a better separation of concerns. You have your business on one part, UI on another part, the infrastructure like networking on another part. And also try to write pure code as much as possible. Pure code or pure functions is a concept from functional programming, where in that paradigm, all functions are pure, which means they don't have side effects, and they compute the result solely based on the arguments they receive. Pure code is also very, very testable, because it's like in any demo for unit test, where you have a calculator class and you want to test that add method. Basically, you just simulate that 2 + 3 makes 5. So input output methods are the easiest and more robust to test. Okay, so we've been discussing about pure stuff, pushing code into business classes. But when you actually try to write unit tests, you need to identify what's a unit. So this is a source of great debates. Basically, how granular do you want to go? So basically, what do you understand by a unit? Is it a class? Is it a method? Is it a module? Well, all that, but it can also be a screen or a web page. Basically, if you consider a unit as a box that receives actions and returns values or those stuff, then everything can be a unit. It's up to you to decide how granular you want to go. The thing is that if you go to granular, you make it harder to refactor the code. But on the other hand, if you go to a high level, you might not get good coverage. You might seem that you have good coverage, but those tests don't really exercise your code base in all their combinations. Yeah, and as I said, treat your units as a box, really, but really as a black box. So what's a black box? This is a black box. So black box testing means that you don't care about the implementation details of the unit. You only care about the unit behaving as the specification said. So you define the behavior of that unit, and when you test it, you don't care about its implementation. And this helps a lot because you will be testing specifications, not implementations. And if you reach that level where you test specifications instead of implementation, then you're in a good place to refactor that code. Because the more you test based on the implementation of the unit, the more you tightly couple the unit tests with the unit implementation. And this makes the unit resistant to changes. Basically, if every time you want to improve something, like you want to improve the performance of the unit, if you also have to change the unit tests, then those unit tests are not that valuable, because that's the exact purpose of the unit tests, to catch you when you do something wrong. But for this, the unit tests need to remain the same. They don't need to change whenever the implementation changes. So this might seem a little bit trivial and might not always be the case. But if we consider an output as any change that the unit does, basically, even if it's a value being returned, a network call, a file saved to disk, a password saved somewhere, or a state changes on the object, if we handle all this as outputs, then we're in a good shape to write unit tests for that. So just think in matter of inputs and outputs. This is a really easy mental model that will help you on the long run. Well, of course, unit test will decouple the unit from the actual network, disk, or keychain, or whatever you have in your system. Just treat them as outputs. So anything that happens during the execution of the unit should be treated as an output. And for this to happen, basically for unit tests to decouple the unit from the outside world, because the unit tests need to run in isolation, we use test doubles. So test doubles are mocks, stubs, spies, fakes, dummies. There are a few of them. What I recommend is to don't rely too much on mocks and stubs, because using mocks and stubs will couple your code with your unit tests. Because if you have some dependencies on your unit and you inject those dependencies, you end up writing unit tests that assert that certain methods were called, and this tightly couples and prevents refactoring. So try as much as possible to use the input-output paradigm. And if you really need to have dependencies like API clients or file managers or others, rely on contracts. So design by contract is a good principle, which says that an interface or a protocol is basically a contract, and that contract guarantees that the entity that confirms with that interface does what the interface says. So let's take an example regarding mocks and stubs. So let's assume we have a worker class that has a state and have a save snapshot method which saves the state of the worker to disk. So first thing first, whenever you have methods that are publicly available, document them, write their specifications. In this example, say what the method does and say what side effects does it create. So this will clearly specify that the method saves a snapshot of the current state, and the date is formatted with a certain format and returns true if the save succeeded or false otherwise. So document, because once you have this documentation in place and you document every behavior, every aspect of the method, then you can write unit tests, and you can and should write those unit tests based on that documentation. As I said earlier, unit test the specifications, not the implementation. So this is a naive implementation, but that's not really testable. We have two pieces of code that prevent us from testing the method. One is the date, the infamous time.now stuff, and then the other one is the write on the disk. So unless we somehow hack the system to return a date we want from the unit test and somehow intercept the writes on the disk, we can't reliably test this. And intercepting writes on disk means swizzling methods and replacing system calls, and that's not fun, and that's not scalable, and also is not maintainable. So one approach would be to use a dependency injection, basically have a data writer and a date provider protocols that replace those implicit dependencies in your code. So now you no longer have implicit dependencies. You inject everything in your in everything that the method needs, and you use those. There is one tiny problem with this approach. Dependency injection is great. However, it might generate fragmentation in your code base, because on one hand, you don't want to create mammoth protocols that have lots of methods. You want to follow the interface segregation principle and give to your object only the methods they need to do their work. So this means that you'll end up with lots of protocols with one method, one or two methods. And this can result to protocol explosion. You will also have to make implementations for those protocols. Many times the implementations are simply straightforward tasks like forwarding methods, but sometimes they maybe not. And another aspect is that the place where you inject the properties and where you use them are two different places. So you somehow have to know when you write the unit test that the value you injected in the constructor are the ones that are used in your method. And this means knowing the code. So this means no longer testing the specifications, because you are no longer treating the unit as a black box. Okay. So can you still hear me?
Yes. Yes.
Okay, because the lights went out. I think there's a power shortage here. Okay. So another approach that I I like is by injecting the dependencies to the method being tested. So basically, we inject the two, instead of having two protocols, we inject functions or closures. And this way, what we pass to the method is what we expect to happen. So we explicitly provide all the implementations, and then the implementation of the method will simply take care of executing them. This allows us injection in unit tests at the call site instead of injecting them in other place. Okay, so how about refactoring? We just saw an example of refactoring here. We started with a unit that writes to the disk, and that writes the file to disk, and then we gradually refactor it by allowing injection of protocols and then injecting closures. So basically, any injection method is okay as long as it allows testability. One thing I recommend when doing refactors is to write unit tests before the refactoring. And even if this implies writing tests that touch the network, that do network calls or save file to disk, or read and write from system settings, just write those tests, because you need to somehow validate the refactoring. Write the tests, run the tests before and after the refactoring. Once you validate your refactoring and you have tests written for the new code, tests that are okay, that follow all the isolation principles, then you can delete the refactoring, the test made for the refactoring. So in the previous example, we had that snapshot method, which reads the date from the system and wrote a file to the file system. And before we made any refactorings, we wrote a few tests that actually interact with the file system and with other stuff. And this validate that the unit works as expected. The problem with these tests is that they are slow, because they reach to the file system, and disk writes are kind of slow and don't allow you to run fast tests. But it's okay, because, as I said, you will keep them only until you finish your refactoring and you validate your refactoring. And once you validate your refactoring, and we assume that when you refactor, you also wrote unit tests, then those unit tests can be used in the future for validating subsequent changes. So these ones can be deleted. Okay, getting back to the problems, to the list of the problems. One of the major sources of headaches in unit testing are flaky tests. Flaky tests really disrupt your flow and negatively can impact your deliverables, because they require defocusing from your current tasks and trying to investigate what happened with those flaky tests. Because most of the times the flaky tests are in unrelated areas of your code base. And since the tests fail on your pull request, you are kind of responsible to investigate them. Because it might well be that some code change you made caused the flakiness. So my recommendation is try to investigate them if you have enough time. Spend some time on them. try to identify what could be the root cause, but don't waste too much time on them. Unless those tests are very important, disable them and re-enable them before merging your feature. So you don't want to get stuck during the development with investigations of Flaky tests that might or might not be your cause. So disable them, finish your work, and re-enable them before merging and see if they are still flaky. It might be they are no longer flaky. It might be that those flaky tests depended on some date time stuff, or maybe some state on the CI machines. And also another recommendation here is to run tests in random order on CI. If every time the tests are on, they run in random order, then it's likely then you'll catch flaky tests sooner rather than later. This helps a lot. The other main bottleneck are slow tests, and slow tests combined with flaky tests give a nasty combination. So slow tests usually occur when writing to disk, when doing network calls. Basically, any writes on the disk or to the network or to the system settings, this add up to the unit testing time. So try to avoid any interactions with external entities. Unit tests should validate only the code, should not reach to the disk, to the network, or to other stuff. Also, limit the reads to, even if file reads are fast, they still add a little bit of overhead. And this accumulates when you have hundreds, thousands of unit tests. So coverage. The coverage can be another cause for friction on the project. You might be tempted to get it as high as possible, and you can go to extreme lengths to try to achieve that. But don't make coverage your primary goal. Keep in mind that business also matters. So try to find a balance between the time you spend on development and the time you spend on writing unit tests that can increase your coverage. Also, don't let not unit tests fool you. By not unit tests, I mean unit tests that are actually integration tests. Those kind of tests give good coverage because they usually go through a lot of lines of code, but they don't add much value in the terms of coverage. And also, branch coverage is equally, if not even more important than line coverage, because branch coverage really gives you is a good indicator of how many code flows, code paths are touched by the tests. Some other bad signs in the code that once you identify them, you can take measures is large tests, for example. Tests that have more than a few lines mean that something went wrong there. Tests should not have that many lines of code. Tests should be short, should be linear, should be easy to understand, and easy to see what happened when they start failing. Large setup code is another bad sign. If you need to write a lot of code to be able to run the tests, it might well mean that your code suffers from the single responsibility principle. Basically, it doesn't conform to this principle. Your code does too much, and this means that you need to write a lot of setup code to make it possible to test. Also, a classic bad sign is custom code needed only for unit tests. This this is not good. Basically, you should not write code that allows you to do unit testing. You should test the code that you actually use in your application, and not some code that you add especially for the unit tests. Okay, TDD. I'll briefly go to this. I intentionally left this at the end and allocated only a slide. I think I can ramble about 2 hours on these topics, and it really deserves a dedicated presentation. But TDD helps a lot in preventing all kinds of problems with your unit test. Basically, you start by writing if you start with the unit test, then when you write your code, because that code is already testable, you will have better architecture, you will have better design, and you increase really fast your coverage. So I really recommend everyone to try TDD. It's not an exotic paradigm as one may think. Basically, it just means you write a unit test and then you write the code. You don't have to write exhaustive code coverage, just a happy flow, and then write the code. It's as simple as that. So conclusions: have the CI set up from the beginning, accept the fact that you can't test everything, make good decisions about what you test and what you don't test, keep an eye on the test runs, watch especially the duration, and try to prevent it early for test suites to take too long. Also, don't release features without unit tests. Features or buffies or anything. Don't have pull requests without unit tests. Also, treat the units as input-output. As we discussed earlier, this is a simple model, a simple mental model that helps you in identifying what test you should write. Also, this goes hand in hand with accepting that you can test everything. Don't struggle in testing untestable stuff. If you see a piece of code that is not testable, leave it alone. Make a plan for refactoring. Better focus on writing some new testable code. And also, TDD is not that hard as it may seem. If there are questions.
So actually, I see that we have an interesting question. Rely on input and output is a great idea, but what if there is no output, like in case of commands? What should the test assert?
In case of commands, I assume these are terminal commands. Well, any command has an output. It does something. Either prints.
Yeah, it does something. Yeah, but I think that the question is that, like, if you have a function that doesn't have any output, but does something.
Yeah. So it does something. Even as I said, it prints something, or it does some other side effect in the system. So the trick here is to make sure that those side effects can be tracked from the testing infrastructure. So as I shown with in the slide with the outputs, any dependency can be seen as an output. A network call, a file system write, a system preference change. So basically, the key here is to inject all this kind of dependencies. To don't have hidden dependencies, because if that command's changing something in the system, then that's a hidden dependency. If it doesn't communicate, hey, I need some interface to change the system. If I directly go to some API, the SDK provides me without making that okay. So basically, inject everything you can, everything the unit needs, make the unit show. So have the unit detail what dependencies it has. because even if it doesn't print anything, that command or function, something must happen. If it happens, it's not necessary.
Yes, for example, if we have a command that doesn't output anything but changes the state of a certain component, you can assert that the state changed. Or if you have a command that writes something in database but doesn't provide any output, for example, that's another, I think, common example, right? If you have a function like save X in DB, doesn't provide any output, but you can assert that the value was inserted.
Yeah, let me try to go to the first example. So like in this example, which says snapshot, if we wouldn't care about the result, the bool stuff, basically we just want to say snapshot, then the side effect would be that file that was written to disk. And yes, that should be the validation that test should make. Now, the key, as I said, is for the unit to clearly state, hey, I need a file manager. I need something to help me write to disk. I don't want for myself to directly go to and write to disk. Mm-hmm. This is a hidden dependency, this over here with data.write. And this should disappear from our code base. We should not have hidden dependencies.
Yeah, and then the next question is, if a test like this test can become an integration test.
Yeah, of course.
But you could also that database is injected like a mock and then assert on it.
Yeah, and I even encourage this doing before refactoring, because you have the unit, and the input of the unit is the method you call, and the output is the database change. So you can have an in-memory database that's fast, and you can do the integration tests if you want to validate the behavior of the unit. But in the end, you should inject the database and not talk at all with the database. And database write, even if it's an in-memory database, adds time to the execution. And on one hand, we want to have lots of unit tests that provide us a great coverage. But if those unit tests slow us down, basically, if you end up with 1 hour needed to run the unit test, then it's also not feasible on the long run. You don't want unit tests to take that long. You want unit tests to be as fast as possible and provide you feedback on the pull request you made. Any code change that causes a bug should give feedback to the developer as soon as possible.
Yeah, and I think you can also assert that some method got called, for example. Some frameworks let you use that. So you can use a mock database and just assert that a certain method that actually writes in the database was called. So, yeah, so regarding estimate, go ahead.
Yeah, so as I said, if you think in input-output, you consider the database an output, because changes in the database are actually the outputs of that method call. Then if you have this mental model, then you can go forward and even end up with this kind of closure injection that I did. It's not necessarily that you need this to do, but if you think in terms of outputs, everything is an output, then you can see you can have a better picture of how to design your system.
Okay. And the next question is, from your experience, what is usually the percentage of writing unit tests from total coding time? When you estimate a task, how much do you estimate for unit tests, for example?
Yeah, I currently estimate somewhere around 30%, but that's because I wrote a lot of unit tests and I have the proper expertise. But when you start writing unit tests, it takes a lot. So it might even take the unit test might take as much as the development time. So if you are not yet comfortable enough, if you don't have yet enough experience with unit tests, I recommend somewhere around 50% allocate enough for the unit test and see how many you can write. And as time goes by and you get more and more experience, you will see that the time reduces. And if you even get to make TDD, and I don't mean TDD all the day, because it might not be always possible to write TDD. But if you end up writing, being more TDD than writing the interactive unit test, then you'll see that that time will even decrease. And because you have tests written before the code, you usually write almost bug-free code, because the tests are already there to catch your mistakes.
Yeah, and I would add also, once you write, like, let's say, one scenario, it's easily to just copy paste the same test and just modify some inputs, outputs to test the other scenarios for better coverage. So
yeah, good point. Yeah, as soon as you have one unit test for that unit, yeah, you can expand and scale, because you know how to, you already have parts of the setup code or the tear down code for the unit test.
well, so I think these were all the questions as far as I see.
Okay, then thank you for participating. If you liked or disliked the presentation, I invite you to share your feedback. This is a QR code that sends you to a link, to Google Forms link. Also, the link will be placed on chat if was not already was placed. So, looking forward to your feedback. And have a nice not WWDC, Programmers Week. Force of habit.
Thank you, Cristian, and I see you all in a bit for our next mobile talks for today. Have a good day.